Now let us see a problem in kinetics. That is, in this problem we will be dealing with the force and the effect of that force on a body. So the question is, a block weighing 1000 Newton rests on a rough horizontal plane. Find the magnitude of a force which is required to give the block an acceleration of 2.5 meter per second square to the right. The coefficient of kinetic friction is 0.25. It is the coefficient of friction between the floor and the block. Okay. So to solve this problem, what we will do is we will draw the block which is resting on a horizontal plane. Okay. Then its weight is acting through the CG, 1000 Newton. There will be normal reaction, and we need to find a force P, the magnitude of force P, which is to be provided on the block so that the block will be moving with an acceleration of 2.5 meter per second square. 2.5 meter per second square. After application of the force P, the block should move with an acceleration of 2.5 meter per second square towards right. Okay, so we should find the value of P. So we have to draw a free body diagram of this block. Now in this we have I will draw the free body diagram. So the block is there, its weight is acting, a force P is applied, the normal reaction produced by the floor, and of course as this force is applied and it is resting on a horizontal surface, there will be horizontal rough surface, there will be a frictional resistance Fk, a kinetic friction Fk will be there, and it will be acting in this direction. So this is the free body diagram of, and this is the acceleration. It shows it is moving towards right with an acceleration of 2.5 meter per second square. Okay, now we will consider the forces perpendicular to the plane. Consider the forces perpendicular to the plane. Now we know that in this direction, that is perpendicular to the plane, there is no motion for the body. That is, the body is in equilibrium in the perpendicular direction to the plane. So we can apply static equilibrium equation. That is, sigma v equal to 0. Sigma v is the net force acting in the vertical direction. So here net force is Rn minus 1000 equal to 0. Rn minus 1000 equal to 0. So this will give you Rn equal to 1000 Newton. So normal reaction is 1000 Newton. Okay. Then consider so if Rn is 1000 Newton, Fk equal to mu k into Rn, or Fk equal to 1000 into 0.25, that is equal to 250 Newton. So Fk is equal to 0.25 into 1000 equal to 250 Newton. Okay. So now consider the forces parallel to the plane. Parallel to the plane. So parallel to the plane, the forces are P and Fk. So here we will apply Newton's second law of motion. Here we will apply Newton's second law of motion, that is sigma F equal to ma. Sigma F equal to ma, because net force equal to mass into acceleration. Okay, normally, or in statics we will be applying sigma h is equal to 0, because in that case the body is not moving in the horizontal direction also, but here the body is moving in the horizontal direction. Therefore sigma F equal to ma. Don't forget to put here ma, otherwise you will not be able to solve it. Okay, so sigma F is equal to ma. So apply the force sigma F. What is sigma F? Net force acting in the horizontal direction. So therefore P is acting towards right, so it is taken as positive. P minus Fk equal to ma. Don't write equal to 0, it should be equal to ma, where m is mass of the body, that is equal to 1000 divided by 9.81, that is w by g into acceleration. Acceleration is 2.5. Okay, so that will give P minus Fk is 250 equal to 1000 into 2.5 divided by 9.81, and that will give you P equal to 504.8 Newton. 504.8 Newton. So that is the value of force required to produce an acceleration of 2.5 meter per second square in this given body of weight 1000 Newton. So that is the force required.